Hi everyone. This video is just a small update to our LMS 2024 project. Specifically, I want to run through a merge conflict that we've encountered because it's an interesting one, but still simple enough. I think that it has a lot of value to learn from. And yeah, let's get into it. So this is still our very first iteration, so not much has gone on. I don't think we've actually fully decided which direction we're going with this project, but yet we still encountered a merge conflict. So let's deal with that. That merge conflict is in this pull request. So if I go to 33, you can see that it has conflicts that must be resolved. Now I just want to emphasize that for people participating, don't worry about figuring out how to deal with conflicts for this project. I just figured this video might be helpful as a reference, even for people outside of the project, because sooner or later you will probably end up dealing with the merge conflicts, and they're more fun to deal with once you know what to look for. So before I get started dealing with the merge conflict, I just want to quickly give a very high level overview of Git, specifically like how Git works. So let's get started. So you might have heard that Git is it uses like a graph data model or data structure to represent the work. So this is how this is kind of the main feature of Git, and it's the graph is the abstract data structure. So on disk, or in real life, Git might work in some fancy way, but the way we should think about Git, especially as developers, is to think of it as basically being a graph. So here's a good diagram from Microsoft about how Git represents its history. You can see we have three little dots. We call these nodes, and these nodes represent a change in the repo. So if I go to our repo here and click here, you see we're on the main branch, and we have 40 commits, it says. So if we were to make a graph or a diagram like this, we would have 40 different dots that lead backwards. And you can see that has these little pointers because, and that's the we might call it like edge, I think, in graph terms, but it's the link between the changes. So the most recent change is C, and it points back to the second most recent change, and so on. So if I go to here, this would be our C because it's the most recent change. I can even click on this to see what the changes were. You can see it's just one extra file, so that's pretty cool. And then it goes back to here, and it goes back to here. So this would be C, this would be B, and this would be A in this diagram. And if this was a diagram representing all of these commits, there would be like 37 more behind it. So hopefully that makes sense. Yeah, we have three. They call it linear commits, and we call it linear because C only points to B, which only points to A. It's not like C also points to A as well. Now that raises a question: why would that happen? Well, let's scroll down. Here's a great picture. You can see we have the same idea of C, B, A, but if you look at all the way to G doesn't point to one other node. It points to two. It points to F and D. And this is the main feature of Git, is the we call this kind of E and F like a separate branch, and basically it represents another stream of work that is occurring. And so what this means is that from D, maybe D is our start of our starting point. We could have different people working all at the same time. So let's see if there's a great picture to find to represent this. Here's a good one. And hopefully I can get to it from here. So in this picture, going back here, we have, the main goes to D and to F. But in this one, I think this is a better way to just to show it, because from our main, they call it master, which is a bit of an older way to describe it, outdated term. We have it leading to the blue stream of commits and the yellow stream of commits. And if I was to make this diagram, I would probably shift this dot to be kind of right under here, because it's not like this changes like after all these changes. They could be at the very same exact moment. Now I'm on the quest. I'm always on the quest to find a good picture for explaining Git, and truthfully, either are too simple or way too complex. It's never. This is a good one. So you can imagine. Let's apply this to our current situation. So here we have our commits. Our latest one is this one that's at 32. 32 resolved 56. So this is our latest commit. We might say that's this dot over here. And then if we go to our pull request, we actually have two open right now, and one of them still a draft, but the same idea. So we have two of them open right now. They're both, in theory, pointing to this one commit. So from main, we have mine, which is for is a review thing, and we have this 33. So from this one spot, this might be the draft one, and this might be the other one. And it doesn't really matter when the changes occur, right? Again, if I was to make this diagram, I might shift this dot to be more closer to here to show that the work can be occurring at the exact same time. And then when we're done, we would want to merge it back in. So I don't know if we can ever find a good picture to show this. But basically what we would want to, if I was to expand this picture to show kind of the future, what would happen is this would get merged into main, and then this one would get merged into main. And they would get merged one after the other, not at the exact same time. And so that shows the power of Git, is that we start from as the same starting point. We work on two different things, maybe at the same time, maybe not, and then we merge them back sequentially. And because I think this is so important, I'm going to actually just go ahead and make my own diagram here in this thing called Excalibur, which is a really good tool if you're not familiar. So actually, I'm going to steal this. I'm going to copy it and paste it in here. Okay. Oh, there we go. You have to do controls. So let's first do my one change, which I thought was important, and that is, it's going to be close enough, hopefully. I would want to add some dots here. Okay, it looks terrible, but please bear with me. So maybe we add some things like there. And so what I want to show is that the changes can happen at the same time, right? It's not like, whoever authored this, I think I put it to this person. Oh, you know what? I can't do that. But let me see. I'll put it. I'll add that as the tiny just to help with this explanation. And then this one was is one I'm making myself. So, and yes, I am reviewing my own my pull requests, which is not a good thing, but for this project, it's just fine. So we have two people working on two separate different things. Doesn't matter, right? Because whatever I commit on here isn't going to affect both, and vice versa. Now, remember what I said is that at some point we want to kind of reconcile our changes. And if you don't know what reconcile is, it means makes sense changes, right? So we have this great situation here where, you know, everyone's just doing their own thing on their own branch, and everyone's happy, and there's no fighting because it's not like I'm overriding anyone's work. But at some point, we do want to get back to main, right? We do have to kind of return to reality, maybe. So let's continue this line out. Maybe I can get a nice gray. Oh, I can actually pattern. Okay, awesome. So let's see if I can. This is definitely not thick enough, so I'm able to do a rectangle. Oh, and of course. So, and this is gonna look terrible, but let's extend this out. So this is the main branch. I'm not gonna. Okay, I am gonna rename it. Sorry. Okay, here we go. So we got the main branch, and then we've extended it out. What would happen in this situation is, oops, I don't want that. What would happen is we would have someone merged into there, and I'm spending too much work getting the colors right, and then getting merged here. So, and we in some repositories like GitHub, you can set rules to make sure that this always happens in a linear fashion, right? Meaning that one happens before the other. It's not like a same time kind of situation. That's a little bit more advanced, so don't worry about that necessarily. What we want to focus on is that we had these separate lines of work all happening at the same time, and then they came back. And I'll draw this really, really crudely. We could have maybe another one, right? And just to make it even more interesting, we could have someone start and then be the very first one in, right? It doesn't matter. Similarly, it doesn't matter that blue finished or got merged into main first before yellow. So it could have been the other way around too. And it doesn't save your colors. So in this case, I'm not sure how best to draw this. But in this case, we could have had something like this, and you go all the way down to there, and then I'm gonna just use orange because I'm too lazy, and we could have had this instead, right? It doesn't matter. The point is that we're having parallel lines of work that get reconciled. It's a little bit like if you worked with threads before. I know that's a weird example, but if you worked with multi-threading before, and you're joining threads, it's the same idea, right? You need to join the threads at some point to synchronize. So that's another example. And this joining process, one way to handle this is through the pull requests. So this pull request is someone saying, hey, I want to put my changes back into main. It's not the only way. There's a thing called trunk development, which is what Google uses. It's kind of intense, so we won't worry about that. But this is just one way. So we have this tool called Git, and then we apply processes on top of it to say, hey, here's how everyone on this project is going to work together. The exact processes you use, they might have strengths and weaknesses for sure. But the main thing is that everyone should really agree to use the same processes so that you know what to expect. And in this project, we use pull requests. So what I'm expecting is, and what I force basically, is that people are going to make a pull request to add their stuff back onto main. So that is Git. Now, the point of this video was to actually talk about this merge conflict. So what is a merge conflict, and what would that look like? So let's see. There's a nice picture. So basically what happens with a merge conflict is two people are wanting to edit the same file at the same time. So imagine in this scenario, even though we're merging, at different times and want to get back to main, imagine this branch edited, it's not going to be very large, but imagine it edited foo.txt. I know that's really small. And up on the blue side, I'll put it blue up here, I guess. It edited bar.txt. In this case, we're never going to have an issue because they're editing different files. However, if this was also editing foo.txt, even though these changes happened later and these happened earlier, right? If I could remove these and pretend they don't exist, imagine it was that you made these changes and then someone later made these changes. Git doesn't necessarily care about when exactly a change was made. It just cares when stuff gets merged and what gets merged, right? Because again, Git is treating these branches kind of as parallel lines of work. So it doesn't necessarily care, that this commit was at like 3 a.m. and this commit was at 4 a.m. It just knows that there's two lines of work and they want to merge to main, and they're ending up merging this, editing the same file. So let's see what this merge conflict looks like. There's a web editor. GitHub provides a few basic tools to deal with merge conflicts. I don't personally like them because they're hard to deal with, and everything in an IDE is better. So I'm going to open this up in I'm just resetting my VS Code to show you the process here. So I'm in VS Code. There's a nice GitHub extension, and here's that pull request. So we can see kind of the same information as a branch with a merge conflict that needs to be resolved. And so from VS Code, what I can do is check out the thing. So it provides a bunch of buttons. I want to check it out. So you can see it's checking out the branch. You can see my branch changed from main to the one branch, and then it brings me up the situation. And what we can see is a few things. One is that Git had added these weird like alligator things, arrows, with stash changes and updated stream. Git will add this like actual text into your file to tell you what has the conflict, and you can see here that someone wants to make a change for her credits, and then there's two more credits down here, and it's in the same file, right? So it doesn't necessarily matter who committed first. Git just sees, hey, you're editing the same file in the same spot. That's asking for trouble. And I did not necessarily plan this for this week, but it's great that we had it because it's a good way to show merge conflicts. So let's see. I click the little merge thing. Basically, when you're dealing with a merge conflict, all you care about is what do you want the result to look like. And so in VS Code, as well as basically, like Vim has this as well. They give you this nice 3-pane view for your merge conflicts. On the left side is, they call it like stash changed. It might be like the incoming change. In this case, it's the stash changes. I'm not necessarily sure what's happening here, but that's fine. On the right hand, this is current. And so you can even see like where it's getting it from. So here it's saying that on origin main, this is what we have. And currently on this pull request branch, this is what we have. And then on the bottom is the result. So if we were to complete the merge, what would it look like? So you can see here that there's no changes accepted. So I haven't chosen either this or this, but I need to choose one or both or what. So in this case, I actually want to accept all of them. So I would want to accept a combination. You can see it's harder to see up here. See if I can blow this up a bit. Oh, this is too much. Anyways, you can see that I can accept the stash changes or accept a combination. So if I click this button, it would only take the changes from origin, right? So basically it'll get rid of what's on that branch, which is not what I want. And then ditto on this side, I can accept the current, which would accept just what's on this branch and not from main. Usually, that's take that with a grain of salt. Usually you'll always want to take some combination. However, there's always going to be examples that disagree or like conflict with that. So it really depends on the situation. And I think that's the challenge of merge conflicts is you need to know what the code is supposed to be doing. So in this case, I want to accept combination. I'm going to just accept the stash changes or the origin first because it technically was on main first, so that seems appropriate. And you can see in the resolution, we got the 1, we got the 2, we got the 3, and it looks fine. That's not like sometimes like part of a function will get pasted into another function and that kind of thing. So you'll have to, and if that happened, you can just copy and paste. Like you can just manually like format the file. Don't think that you need to select the one of the buttons and then pray. If it's really messy, you can just look at what's current and what is incoming, and then you type out exactly what you want. So at the end of the day, you always just take exactly what you want from what you want the file to ultimately look like, and that's how you resolve a merge conflict. So you could delete everything and just rewrite the whole thing from scratch. Git doesn't care. So we resolved one. You can see actually there's another conflict. So Git's pretty smart, and it'll show you conflicts. When it shows you conflicts, it'll show you. It'll try to show you, say like, hey, there's 5 conflicts in this one file, right? And so it's not like a file by file basis. It's really line by line. So again, here we would want to accept a combination. So that's what I'm going to click. Now the thing I'm going to be mindful of. Oh, it looks like maybe if I move. So maybe I think what's happening here is that there was a merge conflict, and then that merge conflict itself with the crazy text it gives you, that was actually pushed. Oh, and I can't change it. So what I'll do, so this is a great example, I'll accept a combination, and then I will just manually delete this line. I'll manually delete this line, and I'll manually delete this line. And I notice, hey, there's actually a duplicate situation here. So I'll manually delete this line as well. And then I'll add a comma here because it's an array. and it says manual resolution. That's totally fine. And then once I'm all done, I can go to the top right here and click, oh, actually, the zero conflicts remain, but this button is still mad. I think we are done. If I go to close this, will it? Oh, it gets happy with me. If you try to close the conflict before you resolve everything, then it'll get a little mad. But in this case, we're good. And so we can go back to the file, and it looks fine to me. And just to be extra safe, I'll go ahead and make a new terminal and just make sure it's running. Just I have to see into the app, right? And then it's .NET run. And I'll wait a while. And one of the nice things about using pull requests is that on GitHub and in many other places, it'll give you, you can have like automated tests that run on the pull request. I'm about to add that to this project. So when you resolve the merge conflict and then push it again, GitHub will run tests on it for you, but it never hurts to do it manually as well. So once I'm done here, you can see that all the other changes have been merged, and there's just a few staged. So I'll just go ahead and click that. And this is kind of the default description, and I'm happy with it. So I'll go ahead and hit commit. Now, the reason why I'm hesitating a little bit is because I do see that there's two people's contributions onto this one branch, which makes me think that maybe someone accidentally used a different branch, which is fine. I'll actually go ahead and make a separate video on that just to keep things short-ish. But yeah, I'll see you guys in that video. But in this case, we can click commit. And I feel like, okay, guess I got committed to, oh, my branch is strangely, if I go refresh, oh, there we go. I was expecting to put my commit back into, I have to push it, but it worked. So in this case, we resolved the commit, the merge conflict, and we added a commit here. But yeah, I'll make another video about the multiple changes that occurred.